Good morning, everyone. See everyone here. My name is Brian Cochran. Steve, thanks for the introduction and bio. Abigail mentioned in her presentation, you just saw that she kind of gave herself a vague title because she didn't know what she wanted to talk about. I have gone even further in making it general. So since 2019, as part of Spectrum Environmental Solutions, I've been involved with a lot of fenceline monitoring projects in Colorado and in California. So much of what I'm going to talk about here today is influenced by the work that I've done in those two states. And I think we can say that there's more fenceline monitoring taking place right now than probably ever before. And there's even more fenceline monitoring that's supposed to be coming online in the near future. So I think this is a good time for us to take a deep breath, stand back and say, okay, well, what's been done so far? What's working? And what needs to be changed? So with that, here's a big picture question. What is the purpose of fenceline monitoring? And so when you want an answer from a reliable source, nowadays you can go to ChatGPT. And so that's what I did for a few of these questions. And ChatGPT, I won't read a whole bunch of slides, but this is one of them where I'm going to read a ChatGPT response. So the purpose of fenceline air monitoring is to measure and assess levels of air pollutants and other HAPs that are emitted from industrial facilities or other sources of potential environmental contamination located near or next to residential or sensitive areas such as schools, hospitals, and playgrounds. Fenceline monitoring helps to determine whether these emissions are within regulatory limits and to identify any potential health risks to nearby communities. By continuously monitoring air quality at the boundary of a facility, fenceline monitoring can help ensure that companies are complying with environmental regulations and taking steps to reduce their impact on nearby communities. This type of monitoring is particularly important for communities that are disproportionately affected by environmental pollution, such as low-income or minority communities. It can help to promote environmental justice by ensuring that all communities have access to clean air and healthy environment. It's not bad. I asked Bard the same question. It was nowhere near this good, the answer. So what's interesting about this? First, like I said, it's pretty good. Second, I think it's interesting that environmental justice is now seen as kind of synonymous with fenceline monitoring. I think if ChatGPT had existed 10 years ago, you asked this question, I don't know that environmental justice gets into the answer, but it's there now. So what else is missing from this, though? And it's kind of implied in fenceline monitoring, but the idea is that you have a facility that emits pollution, and the fenceline monitoring is there to measure what pollution is migrating offsite from the facility. And so that's not explicitly stated here because maybe it's implied, but I think it's worth saying out loud. So, Abigail showed a few slides that showed different news stories and how fenceline monitoring is covered in the news. I'm always interested to see how fenceline monitoring is discussed with a non-technical audience. There was an article that I read not too long ago in a Colorado paper, and there was a quote from an air monitoring expert. This is a well-established expert. I'm not going to use names, facility names here because it's not totally germane, but I think this gets across the point. And he said, the refinery's fenceline monitoring system is not very effective. Tall smokestacks are designed to distribute gases far away, and these chemicals may not register on nearby instruments or on the ground for a while or at all. Fenceline monitoring can provide you certain pieces of information, but doesn't capture what pollution is doing that's coming out the stacks. Most, probably 99% of the pollution goes over the fence line and comes downwind. Is this true? In a way, yes. Yeah. You know, if your fenceline monitoring system is capturing a significant portion of your stack emissions, it doesn't mean that your fenceline monitoring system is being effective. It means your stack's being very ineffective, right? And so that's another part of the ChatGPT answer that it kind of missed. Like, it's not there to measure everything. What are the difference between fugitive and stack emissions? Now, this is a crowd that does this sort of thing a lot, but I'm going to give this answer here because if someone doesn't know, now you can learn. Again, I asked ChatGPT this question and said, well, what's the difference between stack emissions and fugitive emissions? Fugitive emissions are unintended emissions that escape from equipment, pipes, valves, or other parts of the production system. They're not released from various sources: spills, leaks, evaporation. They can be difficult to measure and control because they're not planned, they're intermittent. Conversely, stack emissions, they are intentional emissions. They're released through a stack. They're controlled by pollution devices such as scrubbers, filters, electrostatic precipitators. Before being released into the atmosphere, they're typically easier to measure. And we do measure what comes out the stack with SEMS, just not usually with Fenceline monitoring. All right, so this is my last slide where I lean on ChatGPT, but I said, ChatGPT, is Fenceline monitoring intended to measure fugitive emissions, stack emissions? As ChatGPT used this answer, generally intended to measure fugitive emissions and not stack emissions. So that's all pretty basic stuff, but why are we measuring stack pollutants at the refinery Fenceline? And if you kind of look into this, a lot of it comes back to this EPA report from 2015, their final residual risk assessment for the petroleum refining sector, where they categorized and listed all the HAPs in terms of emissions. And what's at the top of that list is hydrogen cyanide. And if you look at some of the other compounds that are on this list, N-hexane, toluene, and you're a community member outside a refinery and you Google all those, hexane and toluene probably aren't concerning you as much as hydrogen cyanide. And then you look at how much is being emitted. It's a lot. So you're living in an area next to a refinery, you see this, and you ask yourself, why aren't we measuring this at the Fenceline? And so perhaps this is why we're starting to do this. What that report doesn't really break down is fugitive versus stack emissions, but EPA's toxics release inventory, it does. So what I did, and I'll show some data here, and I'm going to add this caveat at the beginning because this is not comprehensive. There's 142 refineries that feed information into the TRI. I didn't figure out a way to download all of them at once, so this weekend I downloaded 11. No, just ones that I've worked at. So there's the caveat. But here's a list of those 11. And so the units on the numbers, not as important here, but again, hydrogen cyanide's at the top of the list. These are ordered in terms of total emissions. Hydrogen cyanide, ammonia, sulfuric acid, and then you see N-hexane. A lot of the same compounds that were just on that last slide, okay? What percentage of hydrogen cyanide emissions are fugitive emissions? 0. Not even 1 pound from one refinery of the 11 that I looked at. Okay. Actually, the top 3, none of them are really significant in terms of fugitive emissions. In the last presentation, we talked about Colorado's Fenceline monitoring rule. There are 3 covered air toxics that the Colorado legislature decided needed to be covered. This is House Bill 21-1189 in Colorado. Those 3 compounds are hydrogen cyanide, benzene, and hydrogen sulfide. So in the case of benzene and hydrogen sulfide, you can make a good case why those are relevant compounds to measure at the Fenceline. Another column there shows in Southern California, the South Coast Air Quality Management District also has a refinery Fenceline monitoring rule. A lot of those compounds are on their list, hydrogen cyanide being one of them as well. But again, hydrogen cyanide, this is only the top 10. If you go do the entire list, it's 39% of the total emissions. So with that, I'd like to transition into two different stories. Spectrum Environmental Solutions, we manufacture open path optical absorption spectrometers using FTIR and UV. Not going to be talking about data from our instruments today. Instead, I want to talk about some data that we collect using point analyzers from other manufacturers that we've integrated into systems that we've set up for refineries, mainly black carbon and hydrogen sulfide. And these are stories that come from California. We haven't talked about about black carbon in this presentation up to this point. Most of us are very familiar with hydrogen sulfide, maybe not so much with black carbon, so I want to spend a little time talking about what it is and where it comes from. So it's basically, think about diesel particulate. Don't want to get too into details here, but it's dark soot, okay? It's highly correlated with adverse health effects, primarily respiratory and cardiovascular. However, there are no real regulatory or health effects guidelines for black carbon concentrations. So we measure for black carbon at the Fenceline of refineries in California. And for many of the compounds that we measure, there are health effects guidelines or RELs to where if we exceed that concentration, the public gets notified. There is nothing for black carbon. So we're measuring black carbon at the Fenceline, we're reporting the concentrations, but we're not notifying the public if we ever see anything elevated. The agency has never set a threshold. On the right-hand side here is the instrument that we're using to measure black carbon. There are different devices out there. This is Met1's version of their atherometer, if you will. It has a reel-to-reel filter tape. Air passes through the filter tape, and then using the property of light absorption in the near infrared region, we can measure the black carbon portion of that particulate matter. Black carbon comes from both stack and fugitive emissions. I'd say about, on average, 70% of black carbon emissions we think are generally associated with fugitive emissions. Okay. Diesel engines, probably your number one source where black carbon comes from. Solid fuel combustion, another significant source of black carbon emissions. What I mean by that is burning of biomass, so things like wood, charcoal, coal, open burning of agricultural waste, another source of black carbon, and industrial processes, oil refineries. Part of the reason why in California this compound is on the list of target compounds for the Fenceline is because the refinery does emit it. So before I start showing data, I want to give a little context here. If you're not familiar with the Southern California area, there's a larger map here on the left-hand side showing downtown Los Angeles, kind of in the upper right-hand corner. Where we do our work is in Torrance at the refinery, kind of shown in light blue, and there's a kind of zoomed in map of the facility then on the right-hand side. So Torrance is about 4 miles from Hermosa Beach in the ocean. It's about 14 miles south of downtown Los Angeles. The facility perimeter is about 4.3 miles. And we have 6 different locations along the Fenceline where we measure black carbon and H2S. Along with each of these locations, we also have an open path UV DOAS and an open path FTIR that shoots in 2 different directions on a pen and tilt auto positioner that moves back and forth. So what I'm going to do is, first of all, talk about some temporal trends in black carbon data, and then talk about spatial trends. What I've done here is shown monthly average black carbon concentrations across all 6 of our Fenceline monitoring sites. And you can see there's a pretty clear seasonal pattern to the data. What we see is in the summer, it's relatively low. In the winter, we see our annual max. It's a pretty significant difference that we see too, about a factor of 10 difference between average concentrations in warmer months and winter months. All our sites trend very well together, but there are some differences. You'll see in the summer months, when the concentrations are low, they're all pretty much on top of each other. But as winter months occur, we see more of a spread. We're starting to see some actual difference in the behavior between these sites. And so I'll get into that more when we talk about spatial trends. A lot of this can be explained by meteorology, pretty much all of it, right? In winter, we have lower mixing heights. So there's less volume for the pollutants to go, higher concentrations. Also generally see lower wind speeds in winter. And so this red line here shows our monthly average wind speeds. Pretty obvious inverse correlation between concentration and wind direction. Dispersion. Part of the other explanation for why we see this is how wind direction varies in the Torrance area over the course of a year. So what this shows here is the relative frequency of wind directions on the y-axis is a percentage, and then different months of the year across the x-axis. So westerly winds are fairly common year-round, but more so in the summer. Northerly winds vary in frequency in the summer, more common in the winter. So what do westerly winds do, and what does that mean for Torrance? Those are winds coming off the ocean, right? Generally higher wind speeds. You just have fresh air that's coming and flushing everything out. When you have winds that are slower in the winter from the north, coming from downtown Los Angeles, coming from the east, the Inland Empire, well, that's where a lot of diesel engines are. Look at black carbon concentrations as a function of time of day. Now, I mentioned earlier that we do see some differences between our different sites, and that difference is really shown here. There's this gray line that kind of sticks out. Okay, I'll tell you which site that is in just a second. But we see concentrations kind of on a diurnal basis peak in the morning, then come down in the afternoon, then come up again in the evening. Here's our daily average wind speed, generally lower wind speeds at night. The sun comes out, solar heating leads to dispersion, higher wind speeds, that pollution gets cleared out. So nothing I've presented here from this orange refinery Fenceline data is new. All right, South Coast Air Quality Monitoring District did their own black carbon air monitoring study before the Fenceline programs all went into effect. You can read the report. It's called MATES, M-A-T-E-S. They've generated all these same figures. They've come to all the same conclusions. The monitoring for black carbon at the Fenceline has only really served to say, yes, you're right. This is what black carbon does in Southern California. There's a more interesting story, though, I think, with the spatial trends. So let's start talking about that. On the left-hand side, a table showing correlation coefficients. So this basically shows how similar each of the Fenceline monitoring sites, the black carbon, are to the other sites. They're all highly correlated. You can kind of see that from the previous charts that I've shown. There's really only one site that doesn't seem to correlate as well, and that's our west site. The highest correlation coefficient between the west site and any other site is only 0.71, whereas you can see some of the other sites we're talking about 0.9495. So it seems to say that we're largely capturing some kind of regional scale, emissions here. I took those numbers from the left-hand side in terms of average concentrations, and that's what the last row at the bottom here is. The highest concentration we see, all right, at any site is 0.73 on average. That's at our northeast site. Second highest is 0.63 at our north site, 0.62, 61, 56, 59, all pretty close. Here's a wind rose, again, showing that in general, highest frequency of winds that we see in Torrance are coming from the west, with other directions being less frequent. So to try and figure out why this site, my northeast site, that's my gray line site, why it is that that site is higher than my others, I conducted a little analysis looking at black carbon concentrations as a function of wind direction. So here's roughly the process that I took. I have 5-minute average data from all these sites. I have 3 years worth now. We started reporting data in April of 2020. I looked at data through March 16th of this year. So that's over 300,000 5-minute averages from each site, multiplied by 6 sites, over 1.8 million. A lot of data. I also have concurrent meteorological data for each of these 5-minute periods in the form of wind speed and wind direction. So what I wanted to do is, for each of these 5-minute periods, I calculated the concentration difference between a given site and the average of the other 5 sites. How is that site behaving differently than the aggregate, the average of the others? And once I have that data, I can start looking at, okay, how do these differences relate to wind direction? Do we see any trends there? Yes, we do. Again, here's our gray line. And what we see is when winds are coming from the north to northeast, that site on average sees concentrations that are 0.2 micrograms per cubic meter higher than the other sites. Conversely, when the winds are from that same direction, my southwest site sees concentrations that are lower on average. It's not immediately intuitive, because if winds are from the north and my monitoring site that's on the north side of the facility sees higher concentrations, that would seem to suggest that we see increased concentrations when winds are actually coming from off-site. So there's a lot of data here. Another way to represent this is to take it and turn it into kind of a polar plot, right? So instead of having all my wind directions be on the x-axis like I did on my last chart, take the wind directions and put them around the outside. So this way, it helps facilitate interpretation of the data. You know, when you see something over here, it's because the winds are coming from the northeast. So when the winds are coming from the northeast, my northeast site reports higher data on average. When winds are coming from the southwest, my southwest site reports higher black carbon concentrations on average. Those sites really stick out. So the other thing I did with this chart, since polar plots aren't really conducive to plotting negative data, is I baseline adjusted everything up, okay? What I'd like to do, though, is to show you each of these lines on the chart individually and show you where it is on the map. So northeast, that's our gray site. Here it is. Southwest. When winds are coming from off-site, we generally see an enhancement of the black carbon concentration on the order of 0.16 micrograms per cubic meter. Our north site. So I've ordered these in terms of kind of biggest black carbon Fenceline enhancement to smallest. So trends are going to be a little less as we go, but in every case, it's something that you wouldn't really expect to see for a Fenceline monitoring program, at least. If we think about what is the purpose of Fenceline monitoring. Our west side, much lower enhancement here. And there's more analysis that can be done to figure out why that is. I will say, though, that in each of these sites along the fence line, we have our instrumentation in an elevated shelter. One of the things about open path monitoring is you need an unobstructed line of sight from your instrument to your mirror. Along the fence line of a refinery, that means you can't really do it 4 feet off the ground. This is our highest site, so our black carbon measurements are taking place here in about 28 feet off the ground. So that's higher above the traffic emissions than it is at our other sites. Could explain why we're seeing a lower enhancement here. And lastly, our west side. So sometimes you're conducting fence line monitoring and sometimes you're just conducting air monitoring at a fence line. All right, the second story I want to talk about, another California-based story. This happened about a year and a half ago. I'd never seen anything quite like it. So for a lead into the story, I'll mention, we have a website for the Torrance refinery that you can go to. The California, the South Coast Air Quality Monitoring District, they have a rule that you have to prepare a quarterly report. You can go and click on the reports tab on the website and view all of our quarterly reports. In that quarterly report is a table. Each month, or each quarter, I should say, it's table 3-4. And what we cover in this table is a list of any hourly concentration exceedances that we had during that quarter. This is where we would notify the public that, hey, we exceeded concentration of something. For this program, 30 parts per billion of H2S as an hourly average requires the public to be notified. In our first quarterly report, there was only one row in this table, and we just filled it in with NAs, not applicable. It's a placeholder. We figured eventually we're going to be having some concentrations, and our report will be ready. People will know where to look for it. And then the next quarter, we didn't have any, and so, but we were ready. We're ready. We're ready. What happened here? 857 hourly average concentrations above our notification level. Table 3-4 was pretty long, this report. It stretched 24 pages. Dan, thanks for putting that together. In that same report, we provide a summary of concentration data for H2S. And what we saw is that we exceeded the concentration level for H2S at every single one of our 6 sites. Not in the same magnitude, but everywhere. Ranged from 34.5 that we saw at our west site. The highest that we saw was 182 parts per billion at our east site. So this started on October 7th and ended, I think, around October 25th. So again, what happened? We first noticed this the morning of October 7th, and we got excited because, we hadn't had a lot of stuff in our reports. And so we saw a 5-minute concentration of hydrogen sulfide above the standard at these 2 sites, but elevated elsewhere. All right, so one site reports above. You're thinking maybe there's a problem with the instrument. They all kind of do it. You're like, I think this is real. What is going on? The next morning, after we had enough data, we ran an analysis looking at relationship between concentration and wind direction. This isn't, I've shown some slides that talk about that already. This is another way of looking at it. OpenAir has a software package in R that you can use. And so what this shows is for each measurement that we took at each of our 6 sites for H2S, the wind direction, the wind speed signified by how far that dot is from the center, and concentration signified by color. All of our sites were reporting elevated concentrations with winds from the northeast, but it was more pronounced at our sites on the east side of the refinery. We weren't the only ones who noticed something. We were pretty sure that it wasn't coming from the refinery, that our equipment was operating as it was expected to, and so we were relieved. And then we started to get information from the news. Not just Torrance has seen this, but Carson, California seems to be the epicenter of this. And so here are a few highlights or excerpts from this article. They mentioned that hydrogen sulfide is very dangerous, and they make sure to mention that it comes from oil and gas refining. At this point, the Air Quality Management District in Southern California has told the news that they've had over 200 odor complaints about the odor up to this point. And the mayor of Carson said they're ready to launch an investigation and litigation may be required. The odor complaints seem to be centered around the Dominguez Channel. October 8th, 2021 was the first time I ever heard of the Dominguez Channel. Perhaps you haven't heard about it either. So here's what it is. It is a 16-mile-long river that goes through Los Angeles. It spans Hawthorne, El Camino Village, Gardenia, Eldorado Park, Torrance, Carson, and Wilmington. And here is a picture of Dominguez Channel. Here's a map showing the path that it takes. It's this right here in blue. Torrance Refinery is located right around here. Refineries in the Carson area are pretty much right on the Dominguez Channel. Dominguez Channel, it handles drainage. It's a drainage endpoint for runoff from the industrial areas. Multiple refineries discharge millions of gallons into the channel daily, but nothing like this had really occurred before. And so the community is concerned. Now, unbeknownst to us, this started before we detected it at Torrance on October 7th. It was really October 3rd when folks in Carson started noticing this, as they put it, pervasive and strong odor in the area, reminiscent of rotten eggs and sewage. At that point, I guess AQMD only had 100 complaints. But this is a pretty cool map. This shows where the odor complaints were coming from. So not monitoring data that we're accustomed to in terms of air monitoring data, but monitoring data nonetheless, right? So on October 7th, the day we noticed, the city of Carson actually put out a press release stating that the foul odor was being released by, quote, an organic material drying out after being left on the channel banks during low tide. So there's still a lot of mystery at this point about what is going on. And then on October 8th, a culprit is identified by the mayor of Carson. It's a leaking pipeline. So this is the mayor's update on Facebook to residents of Carson. Residents of Carson ready to hear it. How long has this pipe been damaged, exposing the public to fumes? I hate how this was downplayed as algae by everyone, even city officials at one point. People who worked the refinery pipeline have known it was H2S for a while. It took days to figure this out. Why can't we shut down this pipeline? It's because the AQMD too cozy with the oil industry. That's why. Well, when you have a Fenceline monitoring program and you're generating elevated concentrations of H2S at the fence line, where do people think it's coming from? AQMD, the last two presentations have been about mobile monitoring. Great stuff. AQMD has their own mobile monitoring vehicle. They did a lot of air monitoring during this. It's super interesting. You can check it out here. But these maps show, like some of the previous presentations, concentrations as a function of where they were driving and very high time resolution data. And we're able to definitely show that it was the Dominguez channel. But still no one really knew what it was. And we kind of, at least within Spectrum, lost a little interest in it until one of our colleagues sent us this article that came out on December 6th. It's on the Washington Post. A smell sickened LA County residents for months. Officials say a fire that torched wellness products is to blame. Say what? All right. Well, when COVID happened, hand sanitizer was in demand. And this company in Carson called Art Naturals had a lot of it at their warehouse. Unfortunately, hand sanitizer is flammable. So when this highly flammable ethanol-based hand sanitizer caught on fire, the fire department showed up and put it out with a lot of water, which washed all that ethanol into the Dominguez channel. This is a photo taken from a helicopter of the fire at Art Naturals warehouse. That mix-off, or that combination of the ethanol running off into the channel combined with the vegetation that was already there, led to an anaerobic environment that led to the production of this hydrogen sulfide. I'd never seen anything like this before. So, in conclusion, the Fenceline monitoring system isn't designed to measure everything. Generally designed to measure the fugitive emissions and not emissions from the stack. And secondly, the purpose of Fenceline monitoring is generally to measure emissions that are generated within a facility that migrate off from the facility. But there's the potential to measure offsite emissions at the fence line. And so care should be taken when evaluating data collected at the fence line and not make assumptions about where things originate from. So I want to give an acknowledgement to some people that helped me put this together. Laura Beth Hale was a great help in putting together the slides on the Dominguez Channel event. Angel Valdenegro is our site operator in Torrance. I want to give him credit because being able to discern very small black carbon trends on the order of nanograms per cubic meter only happens when you're operating your instrument exactly as it's supposed to be operated, adhering to all kind of maintenance and QC checks. So thank him. And then Dan, Casey, and Ian are all on my team and help me manage these programs on a day-to-day basis and generate the kind of quality data that allows us to put together these sort of analyses. So thanks to them. So with that, I think I have time.
Yeah, thank you very much, Brian. That was a fascinating presentation. I want to make sure before anybody leaves that nobody walks off the sign-up sheet. Where it's located. Good. Section, and we do have some time for questions. Oh, you sign up. Okay, very good. Very good. Any more questions from Brian?
Yeah, so the technique that we're using to measure hydrogen sulfide there is basically we're scrubbing out the SO2 from the sample. We're converting all reduced sulfur species that will oxidize at a temperature of 315 degrees or less. So primarily H2S, but some mercaptans. And then using fluorescence to measure it. So it's a Teledyne analyzer that we're using there. There are multiple manufacturers that they generate similar analyzers for H2S.
I have a question about the H2S that you determined is coming from the channel. Was that a assumption based on evidence, or was there any measurements taken? to confirm it?
So I mean, the AQMD, like I said, in their mobile monitoring studies, and this is a little hard to discern, but the channel kind of comes through here. And so they were able to rather conclusively demonstrate that the channel itself was the source of the emissions. What wasn't known is why, what got into the channel.
Network was created due to California specific state rule. How many other refineries in California are subject to monitoring?
Everyone, at least in Southern California. So California special. The rule, or I should say the law that requires Fenceline monitoring came from the legislature, and then California's divided into different air quality management districts. In Southern California, it's the South Coast. In the Bay Area, it's the Bay Area. So they each have their own way of meeting this requirement. In Southern California, black carbon's on the target list. Not certain whether or not it's on the target list for other areas.
And that's going to change. In the next presentation, three people took California district. And then the Supreme Court decided that all the refineries, not just small refineries, measure all the. So now there are 7 in the LA area and the South Coast. Next 2 years it become 40.
So the data is submitted quarterly and then made publicly available on CAQ website. Is that right? They submit it electronically?
Yeah, so the South Coast has a website that has then links to each of the refinery websites. So they don't serve as a central repository for all of the data that's collected. Each refinery will generate its own quarterly report, and you'll see differences in between how each of them present that data.
But you can also see the results of your.
Yeah, that is the requirement, is that real-time monitoring results are available on the website.
Okay, thank you, Brian.
Hang around, maybe.
What are you presenting?
Similar everything.
A quick picture of him in front of the slide before you change it.
Sure.
Thank you.
I think I can download that.
I don't know how they're discrete numbers
Where am I from? Well, Philadelphia.
No, the previous one that we just had. I didn't get this on.
Oh, the
Oh, okay.
right. We're mine,
I just realized I haven't been doing my job as a monitor real well. I didn't realize that the sign up sheet
Yeah.
individual.
Do something or do.
No, we